This is Unit 1 test review, and we're just going to go through the answers so you can see how to solve if you get stuck on any of these questions. The first one, we're looking at divisibility rules. It says so at the top here. First one says find the lowest number that is divisible by 2, 3, and 5. Well, the best way to find which one is divisible by these three is to look for that lowest number. And we've heard that before because of LCM. So if I start to find multiples of 2, 3, and 5, at some point I'm going to find the same number in all three. So for example, let's start with 2. Well, I'm going to skip count by 2's, and that would be 2, 4, 6, 8, 10, 12, and I keep going. For 3's, I'm going to come over here and do 3's. I've got 3, 6, 9, 12, 15, 18, and so forth. And then I have my 5's. So I'm going to come over here where I've got some room, up here. Let's do that. 5. So I've got 5, 10, 15. I've seen a 15 before in the 3, but not in the 2. 20, 25, 30. So I need to keep going on the 2's. 14, 16, 18, 20. I've got a 20, so let me look at 3's. 18, 21, 24, 27, 30, okay? I can stop at 20, so keep going. 22, 24, 26, 28, and 30. But what I notice is in all of them, I have a 30. So that's the first number I have that is going to be divisible by all three of those, 2, 3, and 5. Number 2, how do you know the number is divisible by 3? So really they just want you to write your divisibility rules, which is you're adding up. If you add up the digits, if your sum is divisible by 3, then your number is divisible by 3. That means like the original number they were asking. So for example, example would be 15. Well, if we take the digits 1 plus 5 and that equals 6, well 6 is divisible by 3. We know because we can skip count 3, 6 and land on it. That means that my original number 15 is also divisible by 3. So that's divisibility rule for 3. Number 3 says is 560,055 divisible by 5 and 10. Well, first I want to write that number out. I've got 560,000, so I write 560, and that's in the thousands place. 55. Well, 55 is written like this, but if I put a 0 at the end, that's 550, so I need to put my 0 in front to make it 55. And it wants to know if it's divisible by 5 and 10. Well, remember, we're just going to focus on our digit right here. It ends in a 5. Remember, divisibility rules for 5 is it must end in a 5 or 0. 10 is just, the rule is it has to end in a 0. So for it to be divisible by 5 and 10, this number would have to be a 0. So the answer would be no, because there is not a 0, and that's in the ones place. Okay, number 4, Miss Bratton and Miss Town can evenly divide their classes into groups of 3 and 5. Which of the following could be a possible class size for the 2 teachers? Well, a divisibility, if I look at these, I have, let's just look at 18. 18 is, if I do 1 plus 8, that equals 9. So that's going to be divisible by 3. That would work. But 5, is that a 0 or a 5? No. So this would not be divisible by 5, so that can't be right. I didn't even have to look at my second number. B, same reason. That 18 would not be divisible. C, 20 is divisible by 5, but look, if we add it, 2 plus 0 equals 2. That is not divisible by 3, but it is divisible by 5. Well, we need them both. And see, we didn't even have to look at 24 again, so that's out. 15 and 30, so 15 would be 1 plus 5 equals 6. That would be divisible by 3. And because there's a 5 at the end, that's also divisible by 5. That's supposed to be a check mark. And then 30, if we add it, 3 plus 0 equals 3. Well, that's divisible by 3. That works. And my ones place is a 0, so 5 also works. Something's wrong with my screen there. Okay, it's supposed to be a check mark. There we go. So D is the only one that works for both. Okay. I'm going to go ahead and move this up, which means I'm going to have to erase. So if you need to stop and add, just go ahead and pause your video and catch up with those. There we go. You can see that. Okay. Number 5 says, a teacher has 36 students in a class. She wants to arrange the desks in rows so that each row contains the same number of students. List all the possible ways the teacher could arrange the desks. One has been done for you as an example. So they gave you an example of 2 rows of 18. So what they're using is factors. Factors are going to help us determine the rows that you could arrange them in. And so we're just going to start with, let's see, we have 36 students. Okay, so I'm going to do factors for 36. So I'm going to start 1 and 36. Is 2 divisible? Well, it ends in a 6, so I know that 2 can divide evenly into it, and it's 18. Sorry, my board's off. 3, well, it's divisible by 3 because 3 plus 6 is 9. So I know 3 times something is 36, and it's 12. 4, yes, because 4 times 9. 5, no, because it doesn't end in a 0 or a 5. 6, yes, because 6 times 6 is 36. My numbers are repeating, so I'm going to stop. So how does the T help us with the arrangement of the desks? Well, I know they said rows, but I'm just going to start off with 1. I could have 1 row of 36, but that's not realistic, but I could. But I can also flip-flop that and say it the other way. I could also have 36 rows of 1 desk. Again, not realistic, but I can make that with my factors. The next one, I could have 2 rows of 18, or I could have 18 rows of 2. I could have 3 rows of 12, or 12 rows of 3. I could have 4 rows of 9. I could also have 9 rows of 4. And then the last one, I only have to say it once. I could have 6 rows of 6, because that would work either way. So those are all the ways that I can break up that many desks in a room for students. Number 6, a middle school has 12 math teachers. If each teacher has between 129 and 141 students, what is an estimate of the total number of math students? And justify your estimate. Okay, so we have 12 math teachers. 12 math teachers is not an estimate, that is an exact number. There are 12. But each teacher has somewhere between 129 and 141. There's your estimation piece. 129 is really close to a nice round number of 130. So I'm going to change my 129 and I'm going to make it a nice round number of 130. Well, I'm going to multiply that by my 12 teachers because that's an exact number. So I'm just going to multiply, scratch, lay an egg, okay. 0.0651. So my lowest possible number is 1,560. That's my lowest number that would be possible or reasonable with the numbers given. Okay, then I'm going to go to the other side, and it said the highest that anybody has is 141. Well, 141, I can make that a nice round number too of 140. So I'll multiply that by my 12 teachers because that was exact. Multiply it 0, 4, 1, 6. Okay, so my greatest reasonable number or possible number would be 1,680. Now that's going to be a little bit higher with my exact because of the 141, and then the lowest possible would just be a little bit lower because of my actual 129. But my answer, or reasonable answer, is any number in between these two. Any number in between those two would be reasonable. If it's lower than around 1560, the actual is 1548. If it's lower than that, it wouldn't be reasonable because they have at least 129 students apiece. If you go lower than that, you're saying somebody has lower than 129. Same thing on the opposite end. If you go higher, you're saying somebody has more than 141 students, and that's not where our question said. So if you chose a number anywhere between, that's a perfect answer. Next one is 7 in art class. We have 60 students and they sat in equal groups, which lists all the possible groups. Again, if you have 60 students and you're trying to find all of the equal groups you can make, well, that's just breaking down your number and seeing what are the factors, how can I pair up numbers and they give me a total of 60. Well, I can start with 1 and 60, and then we've got 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 does not go in evenly, 8, no, 9, no, 10, yes, but that's repeating. So what this means is they could have sat in equal groups of, they could have done 1 and 60 and 60 and 1, that doesn't make sense, but they could have done 2 groups of 30 or 30 groups of 2, 3 groups of 20 or 20 groups of 3, and all the way down. So A, we don't have enough numbers. We have a couple of them, but not enough, so A's out. B, same issue. D, same issue. The one that has all possible would be C. And it says all right here, all the possible groups. So you've got to make sure, oops, didn't mean to cross it out. You got to make sure that it's all of them, not just part. Okay, we're going to move down again. So I'm just going to have to erase. If you need it, just pause the video and catch up. Number 8, the 6th graders were planning a trip to the circus. There are 875 students and 10 teachers. Each teacher will take one group of students. Will each teacher have the same number of students in his or her group? Yes or no, explain your answer. Well, on this one, I don't have to do any work because I'm going to look at my 875. They want to take their 10 teachers. If I break up those students, are they going to all have the same number in each of the 10 teachers' groups? I'm going to say no. Because if you look at the number 875, look at this number right here, think divisibility. My divisibility rules for 10 says it must end in a 0 for it to be divisible by 10. This ends in a 5, so 875 is not divisible by 10. So they're going to have some groups that are not going to have exactly 10. Okay, number 11, if you notice the title changed with exponents and prime and composite numbers. So the first one says, write 2 cubed. Well, it says to write, and 2 cubed is 2, and cubed, remember, 3-dimensional is our 3 exponent, times, so so we're multiplying. Remember that dot means multiplication. 3 squared. Well, 3 squared is our exponent of 2. But it says in factored form. Remember, factored form is where we get rid of the exponents and show what the exponents mean. 2 cubed, remember 2 is my base, it's what I see. 3 is telling me how many times I see it. So that's 2 times 2 times 2. Times 3 squared. 3 is my base, it's the number I see. 2 is how many times I see it. So that is 2 times 2 times 2 times 3 times 3 in factored form. Number 10, which is another way to write 4 cubed times 3 to the 5th power. So again, we're just going to factor out. We have 4 cubed, which is the number 4 base you see, and you see it multiplied 3 times. Times 3 to the power of 5, or the 5th power, so I see the 3, and I see it written 5 times. So I go through my list and I look. A has some, but not all. B has some, but not all. C, I look through, and 1, 2, 3 4s, and 1, 2, 3, 4, 5 3s, and I'm multiplying in between, so that might work. D, I have 3 4s and 5 3s, and I'm thinking I have 2 of the same answer. But look what's in between each of the numbers. That's a plus sign. These are multiplying. So this one would not work. It's got to be C because we're multiplying all of those together. Okay, if you flip it over on the back, we are evaluating. Evaluating is they're just asking you to solve the problem. And I look at my problem and I notice I have addition, division, subtraction, exponents, which exponents, remember, are multiplication. So I have all of these operations in one. I know that I need to use my PEMDAS, my order of operations. So I scan from left to right, and I look for parentheses. I have them. I'm going to underline solve. 4 plus 6 is 10. And because, look at this 8, I have nothing in between the two. I'm going to keep my parentheses to keep them separated, or it's going to look like 108. Then I bring everything else down that I have not used. I scan again from left to right, parentheses. I have one, but there's nothing inside of it. So I'm done with parentheses. Then I scan and look for exponents. I see an exponent, I underline it. Remember that this just simply means I see a 3. The exponent says it repeats 2 times. I see it twice. So 3 times 3 is 9. Now bring down everything else that I have not used. I scan, look for more exponents. No. Multiply, divide, it's whichever one comes first. I scan from left to right and stop whichever one I see first. Well, this 10 and this 8 together side by side, that is multiply. So we're going to multiply those. 10 times 8 is 80, and bring down everything else I've not used. I'm still in multiply, divide. I'm scanning from left to right. Stop whichever I see first. I see division. I'm going to underline it. 80 divided by 4 is 20. Bring everything else down. I scan from left to right, looking for multiply, divide. I don't have any more, so I'm done. Last is add, subtract, or subtract, add, whichever one I see first. Scan from left to right. I see subtraction. 20 minus 9 is 11, and I'm done. My process, what did I do first? I added. Then I did the exponent, which is multiplication. Remember the dot. Then I did the 10 and the 8 side by side. That's also multiply. Then I divided and then subtracted. And that's my process, is what happened at each step. Number 12 is write the prime factorization. Remember, prime means you're going to end up with all prime numbers. Use exponents in your final answer. So 4 I'm going to break down with 2 and 20. Circle 2 because it's prime and leave it alone. Break down 20, 2 and 10. 2 is prime, leave it alone. 10 is 2 and 5, both are prime, circle them, leave them alone. So my prime factorization is 2 times 2 times 2 times 5. Let me check. 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40, so it checks. They asked me to use exponents. Well, do I see anything repeating? Yes. I see a 2, and it repeats 3 times. Times 5, 5 is not repeating, so it will not have an exponent. Okay, 13, Kyle watched 28 movies. What is another way to write this amount using prime factorization? Okay, here's our key, prime factorization. Let's get rid of anything that does not have prime numbers. A, 7 is prime, 4 is not, get rid of it. B, 2 is prime, 7 is prime, keeping it. C, 30 minus 2, 30 is not prime, get rid of it. 2 is. And then D, 2 is prime, 7 is prime, so I'm going to keep it. So I've eliminated 2 answer choices, and now I'm only going to look at B and D. 2 squared, well that's 2 times 2, and it says times 7. Well, I know 2 times 2 is 4, and then times 7 equals 28. And 28 is what I'm looking for, so that's a possibility. Then I go over to D, and D is 2 times 7. Well, 2 times 7 is 14. That's not my answer. So the answer is B. For 14, it's just asking first prime, 5 prime numbers. You can use whatever your rhyme was in elementary. Chrissy Prime's phone number, the conga, whatever you did. It's 2, 3, 5, 7, 11. Just the very first 5. Okay, moving it up. For 15, they have a list and they want to know which of the following are composite numbers. Well, remember, composite means they have more factors than just one in itself. It's going to have additional numbers that you multiply and can get your product. So I'm looking at 5, I know that's prime, 7 is prime, 9 is composite because it's 1 times 9 and also 3 times 3, so I'm going to circle that. 14, same thing, I've got 1 times 14, I also have 2 times 7. 19 is prime, 23 prime, 27 has also 9 and 3, so that's going to be composite, that's not just 1 times itself. 31 is prime, 57 is composite. If you added 5 plus 7, that gives you 12. Think divisibility, 12 is divisible by 3, so that means 57 has a factor of 3 in it somewhere. And then 81, again, 8 plus 1 is 9. 9 is divisible by 3, so 81 can also be broken down into more factors. Okay, 16. Sarah wrote a set of prime numbers for her homework. Her set contained 3, 7, 9, 13, and 23. Was it correct? Well, I agree with the 3, the 7, but I do not agree with the 9 because it has factors of 3 times 3. It has more than 2 factors. So I would just write that. No, 9 is prime because it has more than 2 factors. And then for the next one, you're looking at composite. Well, composite, this is composite, but 29 is not. This is prime. The rest are composite. So again, no, 29 is prime because it only has a factor of 1 and itself. Okay, so look out for those prime and composite numbers. Okay, last one. is giving you a scenario, and you've got to figure out how we find the best way to organize the details. So Andy buys a CD. Every time he buys a CD, he leaves the price on it. He wants to know, with all of his CD collection, how much is it worth? How much has he paid for all of these CDs? He knows that each price of the CD will round to one of the following. It's either $10, $15, $20, or $25. We have to figure out what should he do to be able to find the total value of the CD collection. Step L says find the sum of the products of all 4 groups. Step M, separate the CDs into 4 groups according to price. Step N, for each price group, find the product of the number of CDs in the price. Step O, count and record the number of CDs in each group. Well, the first thing, imagine you have a huge pile of CDs. They're all priced different things. What would you do first? Well, first, I want a pile of my $10 stack. I want a pile of my $15 stack. I want a pile of $20 stack. And I want a pile of $25 stack. I want stacks of these CDs so I know how much is in each one. Okay, let's say that there's that many in each one. We're just making that up. I need to stack them according to price. And so that's going to be step M. Step M, first, I've got to separate them and see what I've got and what I'm working with. Okay, then what will we do? We've got left, find the sum of the products of all 4. Well, I'm not ready for all 4 yet. For each price group, find the product of the number of CDs in the price. Okay, that sounds good. I've got to figure out the price for the 10 group and the total price for the 15 group. But step O says count and record the number of CDs in each group. Oh, well, I have to do that first. I have to figure out, okay, I've got how many in the 10 group? I have how many in the 15 group? How many do I have in the 20 group? So I'm going to have 10 times some number to give me total value in the $10 group. Then I'm going to multiply 15 times whatever number total to find total value of the $15 group. I'm going to do the same to 20 and 25. So that's step O. I've got to first count up, well, how many do I have in each? Then let's go to the one that sounded good just a minute ago, step N. For each price group, find the product. Go ahead and you're going to multiply $10 times whatever, 15 times whatever. Okay, so that's step 3. We're going to separate first, then we're going to count and record, and then find the product of, this is each group. And then the last step is, okay, we're going to take our total for the 10 group. So we have a total, if we multiply, then we're going to have a total for the 15 group, we're going to have a total for the 20 group, and a total for the 25 group. Well, then I'm going to add all those totals and get my overall total that tells me the value of everything. Well, that's step 4, is find the sum of the products of all 4 groups. Well, I can't do that until I've done everything else. So my steps, I put a 1 next to M, 2 was step O, 3 was step N, and 4 was step L, matched up, and your answer is C.